Okay, so today we're going to start a new unit and we're going to be talking about solutions and what that means in terms of chemistry. Now, this is Unit 8, and this will be the last unit we will cover this year. This will take us to the end of the school year. Now, solutions in chemistry are very important because most of the chemicals we deal with are solutions. Most of the time, we're dealing with a solid that's dissolved in a liquid. And why is that? Well, if you have, NaCl, which is a solid, a salt, and you had another chemical, like calcium carbonate, and you're going to react these two, they're two solids. There's no way you can put these solids together, rub them together, and they're going to react. What you'd have to do is dissolve each one of them in water to make a solution. And what would happen with the ions would break apart. You'd have sodium ions, you'd have chlorine ions, you'd have calcium ions, and carbonate ions, and they would rearrange and they would react to form a new substance. So solutions, most of the time when you're in a lab, you're dealing with kind of chemicals that is a solution, solid dissolved in a liquid or two liquids, a liquid solution. Now, we'll talk about some types of mixtures. First, solutions are homogeneous mixtures of two or more substances in a single phase. Now, earlier in the year, like in Unit 2, we talked about homogeneous mixtures and heterogeneous mixtures. And homogeneous mixtures were ones where you mixed them together, you cannot tell the individual components. You think about like a soft drink or orange juice or Kool-Aid. You can't see the sugar that's dissolved in the liquid. So that would be a homogeneous mixture and would be considered a solution. Now, heterogeneous mixtures are ones that you can see the individual components, like a chocolate chip cookie or a salad, and those are not solutions. Now, soluble describes a substance that's capable of being dissolved. Another term is the two parts of a solution. The first one is a solvent, and it is the dissolving medium in a solution. It's what's dissolving. It's usually the liquid. If we had a solid, dissolved in water, water would be our solvent, and it's what's present in the larger amount. Now, another term is, the other part is a solute. And it's a substance that is dissolved in a solution. So usually if you had a solar solution, salt would be the solute, and it is what's present in the smaller amount. Now, types of solutions. Solutions can be any of the three common physical states. It can be a solid, and that's a mixture of metals. And what we call that is an alloy. An alloy would be like a mixture of two metals, like bronze or steel. A liquid solution would be like salt water, sugar water, Kool-Aid. Then we have gas solutions would be like the atmosphere, because it's a mixture of oxygen gas and nitrogen gas, carbon dioxide. Now, in terms of solutes, we have electrolytes and non-electrolytes. Now, an electrolyte is a substance that dissolves in water to give a solution that conducts electricity. Now, notice that you've heard people drinking Gatorade for the electrolytes when you feel kind of dehydrated. That's when you need, electrolytes. And a non-electrolyte is a substance that dissolves in water to give a solution that does not conduct electricity. Okay, next, the solution process. There's factors that affect the rate of solution or how quickly a substance dissolves. Any process that increases the number of contacts between the solvent and the solute will increase the solution rate. And there's ways to increase solubility. The first way would be to increase the surface area. If you think about like a sugar cube, when you put that in water, the outside of it's going to dissolve first, and then it's going to have, because it's in contact with the water, then it's going to have to, dissolve all the way to the middle of it. But if you was to crush it up, you increase the surface area of it, and that's the surface that's exposed to the water, and it will make it dissolve faster. Another way to do that is by stirring or agitating a solution. You stir something up and make it dissolve faster. Another way would be to heat the solvent or, increase the temperature. And a lot of times that's a way to make something dissolve a lot faster. Now, there's three main types of solutions, or the way we describe solutions. The first is what we call a saturated solution, and that contains the maximum amount of dissolved solid. And what that means is if you had a solution, a saltwater solution, if you kept adding salt to the point where no more salt can dissolve, that solution is considered saturated. Now, an unsaturated solution contains less than the maximum amount of dissolved solid. So if you add salt water and you could still add more salt and it would dissolve, that is an unsaturated solution. And then last we have a supersaturated solution that contains more dissolved solid than a saturated solution. So if you had a saltwater solution, you added it to where no more would dissolve, and then you kept on adding it, and then you had sugar that wasn't dissolving and it was visible, that would be considered supersaturated. Okay, next, it's a term, solubility. That's a measurement of how much solid would dissolve in a specific amount of solvent at a specific temperature to make a saturated solution. Now, like dissolves like. What that means is polar solvents dissolve polar solutes, and nonpolar solvents dissolve nonpolar solutes. So if you had a polar solvent, it would not dissolve in a nonpolar solute. Next, we have aqueous. That is a solution in which water is the solvent. And then solvation is that the actual process of dissolving. And then water is referred to as universal solvent because water will dissolve more substances than any other solvent by far. So that's why we refer to it as the universal solvent. Now, concentrations of solutions. The concentration of a solution is a measurement of the amount of solid dissolved in a given amount of solvent or solution. It's a measure of how concentrated something is. The more concentrated it is, the higher the concentration number, something we measure in something called molarity. The less concentrated it is, you could to lessen the concentration of the solution, you could dilute it with water. So if you had like Kool-Aid and you had really sweet tasting, you would have a large amount of solute, and that would have a high concentration. And if you added water to it to dilute it, that would lessen the concentration. And then our last term is molarity. And this is the number of moles of solute in 1 liter of solution. Now we use a symbol for molarity. We use a capital M, And we refer to that as molar. Like we have a 2 molar solution or a 3 molar solution or a 0.5 molar solution. The higher the number, the more concentrated something is. And what molarity is equal to is an equation that we're going to be working with tomorrow, and it is molarity, that's for capital M, equals the number of moles of solid over the liters of solution. And usually it's how much is in 1 liter of solution. And so we know how to, find the number of moles. Moles is the amount of something. Mole is different for each substance. We figure out the moles and we can, figure out the molarity. So basically if we had a solution that was like a 3 molar solution, what that would mean is we have 3 moles of a substance in 1 liter of solution. So if I wanted to make 3 moles of salt water, I would add up, 3 moles. I would weigh out 3 moles of NaCl. I'd actually have to convert that to grams to be able to weigh it out on a balance. I'd have to multiply by the molar mass of it. I would add that to a container, and then I would fill it up to the 1 liter mark with water or a solvent, and I would add a 3 molar solution. So the higher the number, the more concentrated it is, the higher the molarity, and then the lower number, the less concentrated it is, and the more diluted it is. And you'll notice that in chemicals that we've used in labs, on some of the labels, it'll have like a 5M solution of a of a certain substance, and then you might be mixing it with a 0.6 molar solution of another substance. But that's what that means when you see that number in a capital M. We'll talk more about that tomorrow.